Okay, section 2.8 is the naming of simple compounds. Now, there is chemical nomenclature is the systematic naming of compounds, and there are 3 areas of this, and I'll probably make 3 different videos with this. So you have ionic compounds, which is the cation and anion. You have molecular compounds, which are 2 nonmetals. We're only going to do binary. And acids, which can either be binary or tertiary. So we're going to start with the ionic. Oh, and all the ones that we're naming are inorganic compounds. We talked in the last section about organic and the fact that we're really not going to go into organic because of the fact that there's a whole 2-semester course about organic chemistry. So we're going to be dealing with the inorganic compounds. And we're going to, like I said, start with the ionic compounds first. So ionic compounds are made up of cations and anions. That was an earlier video. A monoatomic. Mono means one, so one atom ion is formed from a single atom. You can predict the charges of those sometimes for a main group metal. So this, again, if you're going back to what I refer to as being the torrents or the high part of the sections, those are main groups. Basically, it's column 1 and 2, and then aluminum is the only one in group 3. And so it's just basically the column number. So sodium is in group 1A, so it's +1, or I'm going to column group 1. Aluminum is in group 3, so it's a +3. Calcium is in group 2, so it's a +2 charge. Potassium is back in group 1, so it's a +1 charge. So it's simply the Roman numeral or the column number at the top. High number of metallic are exceptions. These are the ones down basically to the right of the transition elements. They start at element gallium, number 31. There are 9 of them. So element 31, 49, 50, 81, 82, 83, and 84 are the ones. Okay, and they can have 2 possible charges, so you can't tell unless you have the name or in a compound which charge they have. So they're the group number or the group number minus 8. So indium is in group 3, so it can have a +3 charge, but it can also have the 3 minus 2 to give me 1. Lead's in group 14, or 4A, and so it is a +4, and then 4 minus 2 gives me +2. Gallium is again in group 3A or 13. Okay, so 13 minus 2, 3 minus 2 gives me +1. The transition elements have typically 2 plus charges. One's a +2 charge, the other one's not. These are columns 3 through 10 in the new numbering system, and you really cannot predict it by looking at the periodic table. So those you have to have either the name or the structure in order to do that. Chromium is a 3+ or a 2+. Copper can be a +1 or +2. Iron's +2 or +3. So those you either have to have the name of the compound or the chemical formula to be able to determine the structure. And then so those 1 through 3 has to do with cations. 4 is the anions. Okay, and so it's the Roman numeral -8, or the other way to think about it, if you do using the new system where it's 1 through 18, then it's simply 18. I'm sorry, the group number -18. So if it is in column, let's say 14, so 14 minus the 18 would give me a -4. So the nonmetals form anions. So phosphorus is in group 15. So 15 minus 18 gives me -3. Oxygen is in group 16. So 16 minus 18 gives me -2. This is in group 17. So 17 minus 1 gives me, 17 minus 18 gives me a -1. And this is in group 15 also. So nitrogen's a 3 minus. Okay. So if it is a main group element or a monoatomic cation, so elements from rule number 1 from the previous slide, it's just the name of the metal. So Ca2+ is calcium, aluminum 3+ is aluminum. For rules number 2 and 3 from the previous slide, I have to tell what the charge is in the name. So Fe2+ is simply iron 2. So you need to know your Roman numerals up to I think 6. Okay, so I is 1, I is 2, I is 3, oops, and IV is 4, V is 5, VI is 6. Okay, so those are the Roman numerals that we'll be dealing with. Okay, and then rule number 4 from the, or elements number from rule number 4 from the previous slide are the anions. Okay, and so you basically take the ending and you change it to I to E. So this is chlorine. Oops. This is chlorine. It's just Cl. And so I replace the INE with the IDE. This is oxygen. And so I replace the YGEN with the IDE. Okay. So what is the basis? That one's kind of a little bit unknown. Okay. And then you have polyatomic ions. Polyatomic ions consist of 2 or more atoms. Okay, they're chemically bonded together and carry a net charge. So here's some examples. Nitrate, NO3, has a -1 charge. Carbonate, CO3, has a -2 charge. That should say 2 minus there. Sulfate is also a 2 minus charge. And ammonium is the only positive one that we're going to be dealing with, and it has a +1 charge. The one with the least amount of oxygen is the ITE. The one with the most amount is ATE. So sulfite is SO3 2 minus, sulfate is SO4 2 minus. And then if there's more than 2, then I have hypoite, 8 per 8. So these 2 here are from the same thing as this. Okay, and then I say less than, so it's hypoite, or more than is per 8. And so ClO has that. So I have ClO minus with a hypochlorite, ClO2 minus has chlorite, chlorate ClO3 minus, and perchlorate is ClO4 minus. And most of the time, the charge of this is called an oxoanion, is the same as the anion. Okay, so sulfur is a 2 minus, sulfate's a 2 minus, sulfite's 2 minus, sulfate's 2 minus. Phosphide is 3 minus, phosphite is 3 minus, and phosphate is also 3 minus. And we will stop this video